When working with traditional art supplies, you expect consistency. But when you build with unconventional materials like organic waste, plastics, or timber offcuts, the physical behavior is highly unpredictable. Skip the testing phase, and you risk your final piece melting, fracturing under its own weight, or sprouting a patch of fungus right on the gallery wall. To safely take raw, unpredictable materials to a gallery-ready state, we use the iterative development cycle. Before stepping into this workflow, gather three specific items: a completed initial material trial, a dedicated notebook for documentation, and your appropriate safety gear. Committing to this structured loop ensures your final piece will be structurally secure, conceptually clear, and fully prepared for public display. Start by looking closely at your initial material trial. Identify its primary physical flaw. Maybe it is brittle, retains too much moisture, or carries a strong odor. There is a strict functional boundary between a material trial and a prototype. A trial asks a basic chemical question: how does this material behave? A prototype asks a structural question: can this material function as an actual piece of art? It is time to build Prototype 1. Take your raw material and apply it to a specific artwork format. If you are working with sago waste and adhesive, press that exact mixture into a small to find relief panel. Before you finish, pick up your camera. You need to photograph the very beginning of this pressing process, rather than waiting to shoot the final molded shape. This physical shift from a loose trial to a defined prototype marks the moment where random material reactions finally connect to your deliberate artistic intention. Put down your tools. The construction phase is over for now. Transition entirely to observing and photographing the dried results of your first prototype. This checklist is your documentation record. Pay special attention to problem observed and next action. When a test fails, log the specifics. If a sago panel cracks, record where the fractures occurred. This essential data dictates what physical variable changes next. In our sago example, a cracked edge indicates the panel held too much moisture, creating surface tension as it dried. The required action is clear. The next mold must be pressed significantly thinner. Through honest, detailed documentation, a series of random physical failures becomes a body of defendable professional knowledge. Return to the workbench. Review your logbook and adjust exactly one or two variables, like drying time or material ratio, to construct Prototype 2. Refinement is rarely about polishing. You are not trying to hide the raw nature of the waste material or make the piece look conventionally pristine. True refinement means improving the artwork's structural integrity, audience safety, and environmental impact while preserving the material's original, rough character. Before you commit to full-scale production, Prototype 2 must pass a final feasibility check. Evaluate three specific areas. Technical: can the structure physically support itself? Environmental: does the preparation process require excessive high-energy treatments? And display: is the piece safe to hang in a room with a live audience? Summarize these answers in your logbook. Write a concise 3 to 4 sentence feasibility statement, concluding whether the material is stable enough to proceed. Passing these specific feasibility checks proves that your artistic idea is environmentally responsible, technically achievable, and completely safe to execute in the real world. You began with a single unstable raw material trial. Step by step, you tested, observed, and adjusted until you produced 2 fully documented, refined prototypes. You now hold hard, empirical evidence of how your sustainable material behaves over its entire life cycle. When skeptical curators, clients, or assessors ask why you chose an unconventional waste material, you can open your logbook, present your feasibility statement, and defend your artistic decisions with data. Your material solution is validated. Your process is safe. You are now fully cleared to take this refined direction and scale it up into your completed artwork.